All right, good morning. We had a couple more questions on the practice test, and I wanted to finalize those. Sorry it took me so long. You know, folks, the thing is about these distributions and the way you read them is that it depends on what mathematician you talk to. It depends on which book you read as to what they're going to say. Whether this rectangular, that number one on letter E was, it's kind of confusing. I guess the thing is here is well, you know what positively skewed look like, you know what negatively skewed look like, you know what normal should look like, you know what bimodal should look like. So by default, a mathematician has thrown in this word rectangular, and in this, what you're doing is you're describing the data display. You're describing the data so that people can so that others can realize, well, if it was a rectangular display, that means that both of the sides are exactly the same. It has the same height all the way across. Everyone knows what a rectangle looks like. So if I come and I grab a rectangle and I draw a rectangle, we know it's a consistent shape. Whether it's that tall and that long, or whether it's that tall and that long, or whether it is a big honking one. We know it has the same shape, so that's what it means by rectangular. Now, I just wanted to demonstrate to you here the great thing of the TI-84. I haven't had a chance to do this yet. I put the list in to list 1. I go second, stat plot. I press enter to go into stat plot 1. I set it up as a histogram. I press zoom 9 because that's a standard plot. I get that beautiful display, and that's how I got this right here. So that's a rectangular display. Okay, let's go on to the next question. All right, on question letter E, question 2, this is a normal display. And it's a normal display because I have a mean, median, and mode that all fall right smack in the middle. So if I was to go through and take these numbers, I'm going to find out that the mean, median, mode is right in the middle. And another thing I can do with that is, let's go second, stat plot, go into plot number 1, change that to list 2. That's where I have the information in. I've already set up. Go zoom 9. You can see the graph. The other thing I can do is I can hit, let's see, stat, calc, one variable stats, and tell it list 2. Press enter. So now I can see that in this case here, my mean is 67. If I scroll down the screen, I see my median is also 67. And my mode I have to do by looking at it. My mode is the most. So the number that shows up the most here is going to be 67, 67, 67. So in that case there, the mean, median, and mode are all exactly the same. They all occur in exactly the same location, and that's right smack here in the middle. And if I go back to my data display real quickly, I hit my graph, I hit trace. You can see that there's my min, there's my min of that, and then there that particular area is 67. So, and this max means that's the boundaries. That's my class limits and so forth. All right, let's move on to the next question. All right, here. Now, your options are negatively skewed. But I have to admit that when I teach this in a class, and what you have to understand is I talk about this for days. I had to verbally talk to students again and again and again. So if you didn't get this right away, you shouldn't feel bad. You should say, oh, it's because of the fact it's online. I haven't had the online discussions. That's why we're recording these videos. And I hope that's why you realize if you just ask me questions that this is when I make my commentary. Okay, so negatively skewed or left skewed. Okay, it's like saying on what side of the data makes my skewness. Not where is all my data at, but where is that one piece of data? Is that one piece of data on the left, on the negative side? Or is that one piece of data on the right or the positive side that's skewing my data? That's pulling my data and stretching it out. Well, in this case here, it's very blatant. All the other numbers are in the 60s and 70s, and we have one number that's a 3. That number is really close to the negative, so it's negatively skewed. The data display really helps us there because we can look at it and see. So let's go in and make our data display. Come here, go down, Second L3 is where I have the list. I go zoom 9, and there we got our data display. Now, I'm going to change my data display real quickly for us. And I'm going to change it to what they call a box and whisker with outliers. Okay, so I'm going to show you here that if I go zoom 9 with that, here's all my data, all stuck together out there in the 60s. I'll hit trace. There's my quartile 1, there's my median at 68, my quartile 3, and my max at 70. But if I arrow on over here, it shows me my mins at 3. So look at that huge gap, and that's going to be what's called left skewed or negatively skewed. Same thing here is like saying what side of the graph is that one piece of data that pulls and stretches the graph out. And on that side, it's going to be the right. And so, I can go into the graphing calculator, but I think here what I'm going to do instead is I'm going to show you the whole idea of the curve and what this does. So if I'm looking at this as a curve, I have something that goes, I'm sorry, I don't have beautiful handwriting like this. And so I have what, instead of being a nice pretty hump right here and being nice round bell shape, I've got all my data stuck on one side, and then it tails out to the left. So to the right, excuse me. So it's right skewed or positively skewed. If I come back to my other data display, it's kind of the same way. I have this nice pretty curve right here, but instead of being symmetrical on both sides, now it tails out way over here. Alright, so there's my little conversation or commentary on skewness. And I got one little more video I'm going to record, and then I'll have a couple videos up for you to take a look at. Alright, good luck. Ask questions. I love to help y'all.